Hello and welcome to our demo today. My name is Tim Darnell and I'm a Senior Technical Marketer for the Portworx group here at Pure Storage. Today we're going to demonstrate a new feature for those of you who are running Pure FlashBlade called FlashBlade Direct Access. FlashBlade Direct Access allows you to provide your development teams with on-demand self-service of NFS file systems hosted on your FlashBlades themselves simply by the developer requesting a PVC through Portworx. There are a few prerequisites in order to use FlashBlade Direct Access with Portworx. Your FlashBlade needs to be running Purity 2.2.0 or higher. Your Kubernetes worker nodes need local block devices so that we can create one storage pool and our journal devices. You need the latest NFS packages installed on your Kubernetes worker nodes. The FlashBlade NFS and management endpoint IPs must be accessible from all of your Kubernetes nodes. And you should have already set up your secret, management endpoint, and API token on your FlashBlade. Let's review the demo workflow before we start. I've just installed a fresh Red Hat OpenShift 4.8 cluster, and I'm going to show you how to provision an on-demand NFS file system backed by FlashBlade, which will be presented as an RWX PV in OpenShift via Portworx. We'll then configure the OpenShift internal private registry to use this storage and scale it so that it is highly available. The first task we will complete is to create our pure.json file, which contains all of the information that Portworx needs to interface with the FlashBlade. We'll then create a Kubernetes secret from this file. The second task will be installing Portworx Enterprise into our OpenShift cluster. Portworx will detect the secret created in the previous step and enable the FlashBlade Direct Access feature. Next, we'll configure the storage class that references our FlashBlade through the Portworx provisioner, and then create our persistent volume claim for our internal private registry backing storage. We'll then verify the PV in Kubernetes and Portworx and take a look at the resultant file system in the FlashBlade UI. Finally, we'll assign our PVC to the internal private registry as backing storage, enable the registry operator, and scale the image registry so that it is highly available. Let's get started. Okay, so informing the Portworx installer that we want to use FlashBlade Direct Access is really simple. Let's go ahead and log into our cluster here. So the only thing that we need to do is create that pure.json file that I was describing earlier. And that's going to contain our management endpoint IP, our NFS endpoint IP, and our API token for the FlashBlade that we're targeting here. So I've already created a pure.json file here. And you can see it's very simple. If you've used the FlashArray integration with Portworx before, this might look familiar. Instead of FlashArrays, we're just listing FlashBlades here. We're giving the management endpoint, the API token, and the NFS endpoint. So let's go ahead and create our secret here. And we're going to call it px-pure-secret. And we're going to put it in the kube-system namespace from our pure.json file. Okay, so we've got our secret created. Now let's go over and start installing Portworx Enterprise. Okay, so since we're installing on OpenShift, we need to install the base Portworx Enterprise operator from Operator Hub. So let's pop over here. We'll do a search for Portworx. Select our Portworx Enterprise operator. Very simple. We click the install button. We can take all of the defaults here and click install and wait for the operator to be installed. our operator was successfully installed. Our next step is to head over to PX Central. Now I've already generated a spec for us to use here to install on OpenShift 4, so I'm just going to grab that kubectl command and head back over to the shell. Now, since I'm using the internal key value database for Portworx, I need to label all my nodes as metadata nodes. And then we'll go ahead and apply the spec to create our storage cluster and storage nodes. Okay, so we can view the status of this by taking a look at all the pods in the kube system namespace. And let's just watch this. Okay, so all of our Portworx pods are healthy now. Our storage cluster should be up and running. So let's take a look here at our pixie-cuddle status of our cluster. Okay, so you can see our Portworx cluster is healthy. You can see the 100 gig disks that I assigned to each node. We have a total capacity of 291 gig in our storage pool. And we have our 3 gig journal devices. So we've got everything necessary for our FlashBlade Direct Access volume creation. So now that we have Portworx installed, let's go ahead and create our storage class, which will allow the creation of the FlashBlade NFS file system through Portworx. Very simple here. We're going to name our storage class FlashBlade Direct Access. We're going to be using the Portworx provisioner. And these parameters are what tells it to use the FlashBlade itself. So our backend is going to be set to pure file. And then we can provide any export rules for NFS that we'd like to be applied to that file system on the FlashBlade. These mount options that you see are just standard CSI mount options within Kubernetes. So you can see since we're using NFS, we're going to tell it to use NFS version 3 over TCP. Let's go ahead and create this. Okay, and so we have our storage class created. And now we can go ahead and create a persistent volume claim using that storage class. So I have some YAML pre-generated for us for our persistent volume claim that we'll be using for the internal private registry. Let's take a look at that real quick. So we'll be creating a PVC with the name NFS Registry PVC in our OpenShift image registry namespace. We are going to create a RWX volume since we're going to be scaling the number of registry pods after we enable the registry. Red Hat recommends a disk no smaller than 100 gig for the backing store for the registry, and we'll be using our FlashBlade Direct Access storage class to create this PVC. So let's go ahead and apply this guy. Okay, so we've created our PVC. Let's take a look at it real quick. Okay, great. There's our PVC and it's bound. Let's take a look at the resultant PV. There's our PV. And now if we do a pixie-cuddle volume list, we can see that there's our Portworx provisioned FlashBlade NFS file system. So let's go over to our FlashBlade here, And we'll sort by created date. And that looks to be our NFS file system that was created. A nice feature here is that we append the PV ID to the file system name. So let's just go ahead and copy that and then come over here, and if we do a OC get PV with that PV ID, we can map back from the FlashBlade UI to the PV in our Kubernetes ecosystem. So now that we have our volume created, we are ready to go ahead and integrate that into the OpenShift image registry as a back end. So let's go ahead and do that. The OpenShift image registry comes unmanaged in a fresh OCP cluster install. So we're going to do a few things to it before we enable it. Let's go ahead and edit its config. Okay, so we're going to come down here in the spec and we're going to go ahead and add our storage. And set our claim name to the PVC that we created. Okay, we're also going to set the management state to managed to enable the registry pods. And we're going to deploy 3 of those pods. So let's save that config. And if we do an OC get pods in our registry namespace, we can see our registry pods are being created. Let's just watch this real quick until they're done. Okay, so we can see all 3 of our registry pods are running now. Let's just wait for our cluster operators to all become healthy. And you can see that our image registry operator here has been healthy since 51 seconds ago. So our operator just got deployed and is up and running now. Let's just wait for these last API server operators to become healthy and then we'll move on. Okay, it looks like all of our operators are done progressing and our cluster's healthy. So let's go ahead and push some container images into this registry and go check the FlashBlade UI. So before we push an image into our private registry that's backed by FlashBlade, let's go to the UI. And I just want to show you that there's 0 bytes consumed on this file system right now. So let's come back here and I'll run a short podman script here. And what this is going to do is just pull a hello world image from Docker.io and then push that up to our private registry and deploy a resultant container from it. Okay, so now if we come into our FlashBlade UI and let's just go in and take a look, you can see that the data is starting to populate back into the UI in terms of used space on that NFS file system that's backed by the FlashBlade. That's it for this demo. Until next time, thanks for watching.